In kinematics, we just learn to describe motion. In dynamics, we study how motion is affected by different things such as forces and torques. Let's start with Newton's 3 laws of motion. The first law says, if the net force acting on the object is 0, an object at rest will stay at rest. An object in motion will continue to move at constant velocity. The first law is also called the law of inertia. The rotational counterpart for the first law is what do you think is the rotational counterpart of force? It is torque. So it's if the net torque acting on an object is 0, an object with no rotation will stay with no rotation. If an object is rotating, it will continue to rotate at a constant angular velocity. What is inertia? What is the closest thing to inertia? What is the measure of inertia? Let's see. A heavy train car has a high tendency to stay at rest if it starts at rest, or to stay in the same motion if it is already moving. It is hard to change the motion of a heavy train car because it has a large mass, which means high inertia. It's much easier to change the motion of a small toy train car because it has a small mass and a low inertia. So the closest thing to inertia is mass. Mass is a measure of inertia. By the way, momentum is not a measure of inertia. For example, a heavy train car at rest has no velocity, therefore no momentum, but it still has large inertia. The second law says net force equals to ma. So the first law is just a special case for the second law. Because if the net force acting on the object is 0, that means the acceleration is 0. That means an object goes through constant velocity motion. At rest, it just means that constant velocity is 0. So the second law's rotation counterpart would be net torque equals to, now this here is not mass. It is the rotational counterpart of mass. Mass is a measure of inertia, so its rotational counterpart is called the rotational inertia or moment of inertia. And we use capital I for it. We will learn more about this inertia in later lessons. And the rotational counterpart for acceleration is the angular acceleration, alpha. So it is net torque equals to I alpha. The third law says, for every action force, there is an equal and opposite reaction force. So, of course, the rotational counterpart is, for every action torque, there is an equal and opposite reaction torque.